Hello everyone. Today we are going to be talking about advanced vector extension. My name is Gayatri Murali. I'm a software engineer working on open source Hadoop projects. The agenda for today's discussion is going to be introduction to AVX, different kinds of applications that will benefit from AVX, some code samples to see how you can integrate AVX into your existing code base, and a little bit of introduction to AVX2 and AVX512. Introduction to AVX. AVX is a new 256-bit instruction set extension to Intel SSE. So if you're already familiar with SSE, you would understand that SSE is a 128-bit instruction set. So AVX is doubling the size of instruction set registers that are available. So what does this mean? It means that, let's take this operation for example, which is A equal to A plus B. For this operation to happen, internally how this gets converted into micro level assembly instruction is as follows. It does load the value of A into a register, load the value of B into another register, and then load the value of A plus B into A. So this gets broken down into three different instructions. Now with 256-bit register space, you could execute more of this instruction in a single CPU cycle instead of what it happens with the 128-bit register space. So it basically helps in speeding up your program. AVX introduced 3 and 4 operand instruction format. What this means is that instead of doing A equal to A plus B, internally now what happens is the result of A plus B is stored in a different register. This is called a non-destructive syntax because the original value of A is preserved as the result of A plus B is stored in C. And we talked about this already. The width of instruction register is changed from 128-bit to 256 bits. And also to 512 bits, we will talk about it in a little bit later. When AVX was introduced, it was only primarily for floating point instructions. But right now, the support is also added for integer operations. What does it mean by enhanced data rearrangement instruction? Let's say you're doing a compare of two objects, and when you're doing this compare, you want to rewrite the first 8 bits of your object with zeros, or your last 8 bits with zeros. You want to append something to your data, or you want to remove something from your data. So all of this can be done in a single instruction because AVX introduced a lot more complicated instruction sets along with it to perform more complex operations. Fused multiply add is also another form of sophisticated instruction in which you can perform both multiplication and addition in a single instruction. You can see an example here. I would like to keep a note to it because we're going to be discussing about fused multiply add again when we discuss AVX2 and AVX512. Fused multiply add is a way in which you can do both multiplication and addition and store the resultant data in one of the registers or one of the operands itself. So if you are a programmer, be it Java, C or C++ or even assembly level programmer, what is it that you need to do to take advantage of AVX? First, you need to identify hotspots in your code using any of the profilers that Intel provides or any other third-party profiler as well. What does a hotspot mean? A hotspot in your code means that piece of code which is consuming maximum amount of time. So let's say you're running your program through a profiler and you see the CPU is at 0% utilized. So that's your hotspot because your CPU is waiting for something to happen, for some resource to get freed up. Or your CPU might be 100% utilized, but you might not be seeing anything useful being done in that 100% utilization, meaning your CPU is still waiting for a particular operation to finish, or for an IO to finish or network to finish. So it is important that you identify hotspots in your code so that you know which part of your code should be optimized. Before you jump into handwriting your Java or C++ code for using AVX, you should first try the compiler switch that comes with Intel compiler, which is QAX AVX. So if you use this switch, what the compiler does is it automatically vectorizes your code for AVX. We'll talk a little bit more in detail about how the compiler does this. you have to measure your benefits. So let's say you have a media application and your performance is measured using frames per second. Before AVX, let's say you are seeing X frames per second, and after using this switch you're seeing X plus 5 or X 2X frames per second. That means you are seeing some benefits. Measure your benefits. Sometimes it can get worse, so we need to investigate why it gets worse before we proceed. So measure benefits and repeat this process again until you get your desired performance. AVX is supported by most modern operating systems. So what are the kind of applications that will benefit from AVX? AVX will immensely benefit any floating point intensive applications like in multimedia, scientific and financial applications, video encoding, decoding and image processing. It's very important to identify the right kind of application before you decide to porting to AVX. The reason I mention this is it is important to make sure that your application will benefit from AVX. Otherwise, the effort that you put in porting into AVX might not yield you the required performance gain. Okay, so now let's assume there is this piece of code. This is a simple matrix multiplication. The loops are very simple. Let's say we want to go ahead and vectorize this loop. We want to use AVX for this particular loop. So for a high level programmer, let's say you're a Java programmer, you don't have to worry about how the CPU is processing these instructions, but you want to make use of AVX. So there are two things you can do. One is create a JNI pipeline and make a call from your Java code into C++ and write this. Let's say this matrix multiplication is being called within your code thousands of times, right? So it would benefit you immensely if this particular portion of code is completely vectorized and optimized. So how do you do this? So if you're a Java programmer, write this piece of code in C or C++ and make a call from using JNI from your Java program. Or if you are a C or C++ programmer, use the QAX AVX switch from the Intel compiler to automatically vectorize this particular piece of code. You don't have to worry about anything. Just use the switch, compile your code, build your code and see if you're seeing any performance gains. You don't have to make any changes to your existing code base. If you're a Java programmer, I reiterate, use a JNI, write this in C or C++ and see if you're seeing a benefit. Okay, so let's assume that you're a C or C++ programmer and you're using the switch. What happens internally? Internally, this particular loop gets unrolled. What is loop unrolling? So I would like to show you an example of what loop unrolling is. So if you look at this Wikipedia article, you see that here is a normal loop which runs from 0 to 100, and what you're doing, you're just deleting x. It's a fairly uncomplicated loop. Now what I do here is I do delete x up to x plus 4 within the loop, and I increment x by 5. So instead of running this loop 100 times, I run this loop 20 times, thereby saving time. So this is a manual example of loop unrolling, and the compiler does this for you. So can all loops be unrolled? Not necessarily. So for loops to be unrolled, it has to follow certain criteria. You cannot have branching statements within the loop. What do I mean by branching statements? If you have a if condition within the loop, depending on which your code path is going to vary, then the loop cannot be unrolled. If you have function calls within your loop, then your context switch happens, your program moves from your loop to a different function, then it cannot be unrolled. The compiler will give you a detailed report of what can be unrolled and what cannot be unrolled, right? So loops that can be unrolled, the compiler will go ahead and unroll it, thereby giving you a significant improvement in time. With AVX, 4 multiplication and 4 addition operations can be performed in a single instruction because you have extra register space. So what do you need to do to get this benefit? You just need to use this particular switch. So here we discussed what kind of loops can be unrolled. So it is very important to identify that piece of code which gets called the maximum number of times, or which is going to consume the maximum number of time, and see if you can optimize that piece of code. What is AVX2 and AVX512? AVX was introduced back in 2011, post which significant improvements have happened with respect to AVX itself. AVX2 is also a 256-bit instruction register, but they support integer operations. And AVX 512 is a 512-bit extension to the 256-bit advanced vector extensions. AVX2 also support the fused multiply add that we talked about. Okay, so I just want to introduce AVX intrinsics to you before we close on this discussion. So there is an intrinsics guide that is publicly available. So let's say you have a C or C++ code and you would like to use AVX. How do you do that? So just go here and click AVX and choose the kind of operation your function is doing. So let's say you're doing compare operation. What this does is it gives you all AVX instructions for compare operation. If you click on this, you will also be able to see a C style function that you can use within your code to take advantage of this compare operation with AVX. Again, this is for someone who's willing to handwrite code. This is for someone who's not willing to use the switch and would like to write on their own AVX instruction, right? So you can see that this is 128-bit, but you also see 256. AVX also supports 128-bit, but if you want to go for 256, this is what you would use. If you want to use AVX2, then you see that a suffix of I is added here. What it means is it supports integer operations as well. So you could see different instructions here on how to use. So this is a compare equal, CMP-EQ. So this is compare greater than. So these instructions are pretty self-explanatory, or you can also see what it means here, right? So you can use these instructions and hand code your assembly or your C or C++ program. So to reiterate what we discussed today, identify a piece of code that is a hotspot in your program or which consumes maximum amount of time. Optimize that code initially by using the compiler switch. Measure the benefits. And if you don't see benefits, consider handwriting your code and measure benefits. It is also important to identify the right kind of applications that would benefit from AVX. That's all I had for today. Thank you for listening. Thanks.